Today I wanted to talk about whether the Sapphire project is a scam, real science, or what. And this is another request from a subscriber that I talk about the Sapphire project. And I come up with the questions about scam or real science from a Professor Dave Explains video where he does a severe takedown on the project. And if you're not familiar with the Sapphire project, it is a plasma experiment that is supposed to look sort of like the sun, where they take a spherical ball, pump in helium, put it under, well, they don't say the voltage, but put it under a presumably high voltage and high enough current that you get plasma surrounding this metal ball. And their claim is to try to show that it supports their electric sun model of sun. And the electric sun model involves treating the sun like a metal anode, where you have current coming in from the poles and then exiting essentially like the solar wind. And this allows there to be plasma filaments that connect all the suns together. And in the Professor Dave video, he did traded some emails with a physicist that worked on the project named Lowell Morgan. And he made the comment, I don't think the electric universe, which basically claims that all the stars are like light bulbs strung together with wires, is even worth wasting time thinking about. So he didn't think a whole lot of the theory. And I don't think a whole lot about that theory either. And while we know that there are filament structures and galaxies form along these filaments and stars more locally form along these plasma filaments, I think that has more to do with how the matter is collected during the star formation and galactic formation process, rather than being a source of energy with huge currents traveling long distances across space to light up stars like light bulbs. And so it's in opposition to the idea that stars are collapsed and pushed together due to gravity, which causes fusion, and the fusion gives energy that makes the whole star plasma and gives it its plasma characteristics. And in both models, the star is plasma, so there's no disagreement on that. And in both models, all the characteristics are due to plasma interactions. It's just the people who support electric sun like to claim that, yeah, the star is plasma, so the electric universe model's right. I know I'm oversimplifying for people that are fans. But they can't claim that credit. It's plasma either way. But to go on, they were funded by an organization called the International Science Foundation. Well, that sounds great. I mean, there's a National Science Foundation in the US that funds a lot of things and is very important to science. But the International Science Foundation isn't that. It's an organization founded by supporters of the electric universe as a funding vehicle for Sapphire. And as far as I know, the only thing they funded. And so they try to make it sound like ISF is some important international organization that funds projects. No, it's not like that. It was just set up to fund Sapphire, and it's part of the Electric Universe Thunderbolts organization. And so were the ISF investors scammed into supporting it? No, of course not. They're in on whatever this is, this attempt to prove that the electric universe model that they promote is correct. If anything, if there is a scam, they're in on it. And that's a bigger question about what do you call the electric universe? And maybe I'll tackle that in another video. So some of the basic negatives you see, and Professor Dave does a more in-depth takedown than what I'm going to do, is the sun is electrically neutral. It's not charged like an anode. In order for gravity to be the dominant force, since gravity is 10 to the 36 times weaker than electricity, that means that the number of electrons and protons has to be equal to more than 36 decimal places. So 38, 40, something like that, at least. And so there isn't a charge. We know that. So that doesn't explain how you would have a current when there's no charge. There's also no evidence that the sun is a metal anode, or it has gas plumbed into it. So these things are artificial. The experiment's an artificial way of making a plasma experiment that looks sort of like the sun, but isn't anything close to the sun. And there's no current that we know coming into the poles. It's never been measured. So unless someday there's a measurement that shows that there's really currents there, they're really kind of stuck. Another thing is that the solar wind is net neutral. It has an equal number of positive ions and protons versus electrons. And there's no indication that electrons are being sucked back in immediately into the sun because it's an anode. The solar wind is traveling outward with ions in all directions. And so we've known that everything from the photosphere to the solar wind is a form of plasma. And as I said, the electric universe doesn't get to say, oh, it's plasma, we're right. No, everyone knows it's plasma. Now, there may be ideas from different plasma physicists in the electric universe or not that are better than other ideas, and that's fine. The astrophysics from 100 years ago didn't take plasma physics into account the way it should have. And so plasma physics and the way it is involved with astrophysics has evolved over time and is still evolving. We're still learning more about the sun. And that's okay, that's the way science works. And then another thing I wanted to point out is plasma experiments, not too dissimilar from SAFIRE project, have been going on for over 100 years. This thing is not anything new, and it doesn't, well, it does have some things that bring up new questions because we're not certain about why some things in the experiment behave the way they do. The basic plasma physics hasn't changed. And so, did the SAFIRE experiment prove the electric sun model? No, not at all. But as Lowell Morgan called them, the true believers will say that it does. And there's really no point to arguing with true believers because they're not thinking rationally. And that's part of the problem with the electric universe model, and the electric universe in general, is that some of their foundations are based on fiction. But I'll get into that another time. So what did the SAFIRE project show? Well, it did show some interesting things. Monty Montgomery has reported in an interview that they saw on a mass spectrometer atomic mass 3 and 4 elements, which would indicate tritium and helium, and possibly even helium-3. He wasn't specific, but tritium and helium, almost a certainty. Although he claimed that, well, we're not saying it's helium. Well, if you used a mass spectrometer, you know whether it's a helium or not. So he's being disingenuous by not reporting it. And they did, when they did scanning electron microscope analysis, where you can shoot electrons and look at the surface. When the electrons hit, they excite elements in what's called X-ray fluorescence. And so there's a probe that you can add to a scanning electron microscope that they call EDS, or EDAX is one brand. And it gives you the elements on the surface by measuring the X-ray spectra that comes off. So they did that type of analysis, and when they did, they found phosphorus, sulfur, chlorine, potassium, calcium, titanium, zinc, tin, barium, lanthanum, cerium, and other elements they don't want to talk about. And there was also aluminum and silicon in there, but it's not clear to me if there may have been aluminum and silicon as part of the experiment, so possibly it got there some way else, or somehow maybe it was transmuted and grew out of the anode, as they claim. And they do show that, based on the SEM pictures, it doesn't look like it's vapor deposition, and I'm willing to go with that. So this showed very clearly that there's some sort of fusion going on, although they don't want to use the fusion word either. And then what they found is, normally when the ball is just glowing and running at low energy, which is called the glow discharge regime, there wasn't any thermal runaway. But that when fusion started happening, they would get more thermal energy. And that makes some sense, of course, that if you have fusion going, that gives you a new source of energy, and your energy will spike. And so these things are all very interesting. Now, J.J. Thomson, who you may know as the discoverer of the electron, did a lot of gas discharge tube work. And he also invented the mass spectrometer. In his papers where he invented the mass spectrometer, he showed that he detected deuterium, tritium, helium, and hydrogen, which he started with. And then when he introduced oxygen, he found neon was being produced. And he also continuously found that no matter how much he cleaned the tube, that he was always getting hydrogen out of it. So it appeared to be manufacturing hydrogen. So J.J. Thomson manufactured tritium, we know for certain, because tritium doesn't occur naturally, because it has a 12-year half-life, so naturally it decays. And so unless there's a source for recent tritium, we don't see it in nature. And he likely, due to weak interaction and fusion, produced neutrons, deuterium, helium as well. And he wasn't the only one. Between about 1905 and 1930, there were a number of investigators that were reporting hydrogen evolving from anodes, even though the anodes had been made free of hydrogen. And they also had helium coming from hydrogen, and then neon evolving when they had oxygen. And it was presumed that if you add helium with oxygen, you get neon if somehow they're fused. And so this was a very interesting line of research that was dropped and not picked up again. And most physicists over the last 70 years have said, oh, it was just experimental error, that didn't really happen. But on the other hand, we do know that basic fusion does happen in arc discharge tubes. So the idea that they get transmutation is not something new. They consider it proof of the electric sun model when it's not. For over 100 years, we've known that you get fusion in an arc discharge tube. Now, the thing that is interesting is getting fusion between the heavier elements. It's one thing to go from hydrogen and then make deuterium and tritium and helium. To make neon from oxygen and helium, that is something that most physicists weren't sure were possible, and even today aren't sure is possible. It's one of those things that needs to be confirmed experimentally if it's true. And all their claims from phosphorus on up to lanthanum evolving on the anode due to some fusion process, that has to be verified experimentally if it's true. And there are ways that we can verify if it's true. And one thing in one of their videos, the more recent video where they're trying to promote the sale, they say that no radioactive elements are produced. Well, that's nonsense. I mean, one thing that we do know is if there are no radioactive elements being produced, then they're coming from someplace else. You can measure the isotopic composition of elements that have more than one stable isotope. And if the isotopic composition matches the natural composition, then it probably came from somewhere that was originally a natural source. While if it has radioactive elements, then you know that the fusion was occurring in relation to those elements. There's an experiment by a group called Quantum Rabbit. Edward Esco was in charge of it, and he published some papers in Infinite Energy magazine where he tried to do fusion between larger nuclei. And his experiment sounded interesting, but there's one experiment where he was fusing iodine with lithium. Stable iodine has a mass of 127, and lithium is mass 6 or 7. And so if you were to combine those, you could get barium-133 and barium-134, and the barium-133 would decay by electron capture decay to cesium-133. So if you're doing this, when you measure it, you get cesium and barium in those isotopes. But when they looked at the isotope in barium that they were actually getting from the experiment, it was 138, which is the most common barium isotope in nature. But it would not have been produced in the experiment. And so because of that and other questions, his whole idea that he could get transmutation and fusion the way he was explaining it is highly questionable. And so we can tell if a natural material was added versus having some process of fusion building up isotopes individually. And that sort of analysis needs to be done in order to prove that they're actually getting transmutation of these heavier elements. Now, what are they doing next? They have proposed experiments to do a calorimetry experiment to show that they really are producing energy and heat. And you have to do that as a proof that you're getting excess energy out. They need to do more transmutation experiments, obviously. And they also have looked into being able to remediate nuclear material based on some MIT research that shows that if you have hydrogen with around radioisotopes, it's possible for them to decay faster. And that has to be some sort of weak interaction process that isn't fully understood yet, I don't think. And it's not even clear that this would work with their apparatus, so it would have to be experimentally verified. And so they're looking for funding to continue these types of experiments. And my take on that is I wouldn't put my money into it. And part of that is I've done research in vacuum arc discharge at higher voltage, and I am convinced that vacuum arc discharge is a lot more efficient than this glow discharge or near glow discharge regime work. That with vacuum arc discharge you get more energy, more transmutation, and better remediation, assuming that you get, assuming you're actually getting the transmutation and can do the remediation. And another thing, they talk about making rare earths and selling them, or maybe other elements they haven't told us about. And you're not going to make money selling lanthanum and cerium that way. They're not valuable enough to put that much energy in and go through the refining process. The real expensive rare earths is in the refining, not that they're really rare. For anyone that's done a transmutation type process like the accelerator or cyclotron, the first isotopes you sell to make money are the medical radioisotopes. Of course, they did use fuel for atomic bombs, making plutonium, but you don't want to be making plutonium for third world countries. That's not a good idea. So the medical isotopes would be the first market I would see in terms of taking advantage of the ability to have fusion. And I know a little bit about that because I was the manager of radioactive material licensing for Texas for a number of years. And so I licensed cyclotrons to make medical radioisotopes. So back to the original questions, is it science? Absolutely it's science. It is real science. They have a hypothesis. They come up with an experiment to confirm their hypothesis. They run it. And I don't think that the experiment confirms what they think it does, but they're going to be true believers anyway. I can't do anything about that. So is it a scam? I don't think so. The original investors got what they paid for, or at least they think they did. And new investors, they'll do their due diligence, although I would hope that they would be more interested in advancing the science and trying to make money off this, because I'm not sure that they can make money off of it. But that's up for them to decide. So I do wish the team success, and especially in dealing with transmutation, because that would be a big advancement in our knowledge if we could do large nuclei fusion. So it would be exciting if they're successful. It would be a new way of looking at how the elements evolved in the universe and change our understanding greatly. Well, anyway, I hope you liked the video, and please hit the like button below, share it with your physicist friends, subscribe for my next videos, and if you'd like to learn more about my quantum field theory research and particle theory research, I have books for sale. And I'll link some of the videos that you can watch on the SAFIRE project if you'd like to learn more about it. So thanks for watching.